Hey, we have a brand new IoT show for you guys, and it's about running AI and vision AI at the edge on some cool NVIDIA devices. And we have Paul DeCarlo that is presenting a very cool project, and that's all in the context of hashtag JulyOT. Don't miss that episode of the IoT show. Hey IoT fans, this is Olivier and you're watching the IoT show. Today we have Paul DeCarlo who's here to tell us about AI at the edge with the NVIDIA DeepStream technology. Paul, thanks for joining the show again.
Hey there, Olivier. I'm glad to be here in virtual form, dialing in from Houston. I'd love to talk about this new device that I got from my friends at NVIDIA. This is the Jetson Xavier NX. It is the latest in the line of NVIDIA Jetson embedded devices and packs a really, really powerful punch in an extremely small form factor. In fact, this sucker here is quite some bit of kit. It is got an onboard GPU that's got 384 NVIDIA CUDA cores and 48 cores. One of the things that's also interesting to note on the low number side is power consumption. So actually runs in two different modes, a 10-watt max efficiency and 15-watt max performance that can allow you to take advantage of that onboard GPU and also deep learning accelerators that are available there to perform AI and inferencing down at the edge on your devices.
That's pretty cool. So you've been working on an end-to-end project that includes not just the hardware itself and running AI down there, but also leveraging the NVIDIA DeepStream module. Having several cameras connected to that one tiny device there, which we didn't talk about the price point, but I think it's something that is not just production ready and for enterprises to use, but that consumers can actually also get and build their own solution with that, right?
Correct. And one of the exciting things with this device, which I believe is going to launch at around $400, is that it has this NVIDIA Metropolis line of software, which includes tools like Transfer Learning Toolkit that can let you essentially take pre-created models and sort of add new learnings to them by exposing them to additional training. And also a full-on inference pipeline, which we'll be talking about today through DeepStream. And this allows you to, as you said, take in multiple camera stream inputs. In fact, that can look like this. I've got 4 cameras at my home that are currently attached and being processed by this device right now. And they're running a model that's actually developed using some of our own services here at Microsoft.
Awesome. Well, let's jump in it. I mean, like, people are excited now to see what you've been building and to see the full end-to-end story, right? From, hey, how you deployed that AI at the edge and leveraged the hardware acceleration on that device, all the way up to, I hear, Power BI reporting for the whole family to actually be able to check out the reports on these alerts or detections, right?
Correct. So the first thing here that makes this pretty straightforward to jump into in terms of, if you're already familiar with services like Azure IoT Edge, is the DeepStream SDK is actually available as a module in the Azure Marketplace. So you can just pull that down and start running DeepStream workloads. And these are pretty easy to get going. In fact, they look essentially like a text file that you would then configure to your sources and also say configure to the type of inferencing that you want to run on that device. There's also things you can do to sort of tweak how it's pulling frames and things like that. But once you get that up and running, you can go ahead and deploy that down to a device. So I've got that deployed to a device I've got named Jetson Xavier NX 00. And you can see down here, in addition to some other modules that we'll talk about, you can see that NVIDIA DeepStream SDK is currently running down on the device.
So let me ask you, Paul, real quick. So who's maintaining that module there? Is it Microsoft? Is it NVIDIA? Is it a joint work?
It is a bit of a joint work. So the actual container itself, from what I understand, is developed by NVIDIA, and then it is published in partnership with some of the members of the product group at Microsoft to make it available in our marketplace.
Okay.
Now, earlier when I was showing that demo, I'll bring that up again. You can see this is detecting people, myself here, and it's also detecting this vehicle in the driveway. Now, how it's doing that, we actually developed something called the camera tagging module for IoT Edge, and this is it running. And it makes it very easy to come in here and contextually capture images from RTSP capable cameras that might be on your network. Once you do that, it's very easy to then export those out to, say, custom vision or blob storage. So
that tool is running on, I was looking at the URL up there. That tool is running on the device itself?
Correct, yeah. In fact, if we go here and look at the deployed modules, you can see here that camera tagging module is actually running alongside that DeepStream SDK workload that's also deployed on the device.
And it's in the Marketplace as well as one of the other modules.
The camera tagging module, yes, or if not, I know it is under development within GitHub, and you can sort of build it yourself and deploy it. There may be plans to bring that into the Marketplace at this time, but it's easily obtainable and easy to build and publish into your own repository if needed.
Pretty cool.
So what I did with this, I guess what's kind of cool, I learned that you can actually automate this thing. So I set it up to, I guess, capture, however many pictures it wanted and on 15-second intervals, kind of round robining my 4 cameras over an entire weekend. And that allowed me to get a bunch of different samples of us doing various different activities throughout the view of the cameras, as well as being able to capture different situations in specific contexts. For example, like you can see this light aberration when it's trying to detect the vehicle. That would make it, a little bit hard to maybe detect if it doesn't know of that. But also giving it the ability to see at night, which if you've ever tried any sort of, off-the-shelf object detector models, they often aren't trained for those types of scenarios. But I can tell you that running this at night, unless it gets pitch black, I can actually still pick out some of these vehicles because of training a contextually relevant model using that camera tagging module that we were just looking at.
But did you have to do anything on the camera side of things? The camera technology has some, night vision, capabilities, but you don't have to go with like high res or a high frame per second, right?
Well, there is some tuning involved there. So you do want to try to look at, how can I get the most frames per second while at the same time being able to get, smooth playback. That can take some tweaking depending on what kind of cameras you're using. And I'm also going against some convention in that my cameras are Wi-Fi based. So if they were Ethernet based, it'd be a lot easier to get a lot more frames and a lot faster. So there was a lot of testing that had to be done in order to get it to this point. But due to that, because you can capture these samples in these contextual environments, I can now do things that I wouldn't normally be able to do with an off-the-shelf model because it has been taken, from the context of what those cameras actually see.
I see. Love it. It's actually, easy as well for people who don't have any data scientist training or background to do that training with like very simple things and tools.
Right. And so what's nice too is that once you get this model going, you're able to export it in a variety of different formats. So you're not just limited to these NVIDIA devices. You can actually drop these onto like iOS. You can even create a standalone Docker file to perhaps deploy to a Raspberry Pi that you might have, which is really amazing. But what's interesting here, we're actually using this Onyx format that exports it as a YOLO type of model that runs down on the device itself. And that's sort of how we go from custom vision to running on one of these NVIDIA Jetson devices.
Well, so you basically train the model, export that in the right formats, and then it's the typical IoT Edge upload down there.
Exactly. Yes. So there's also a lot of techniques out there. I know that we've been looking at ways to maybe control this through features and facets like maybe update a twin method or something that can then update the model. In my case, I'm just FTPing it over and then restarting the DeepStream SDK, and it picks it right up for me.
Love it. Okay.
So once we have this model that's been exported down to the device in the format that we need, you'll start to notice that it will generate a lot of data. In fact, this is the data it's generating right now. And you can just see like multiple inferences per second are occurring here. And this kind of poses a question like, what data do I really need? How much do I actually need to perhaps send back to the cloud? Or if I want to get a summary of what my cameras are seeing throughout the day, what would be a good strategy for that? And thankfully, we have a service known as Azure Stream Analytics that runs in the cloud, but can also be ran as a job down on your edge device. So you can sort of see here what I'm doing here. I've created a Stream Analytics query that I also run on the device. In fact, I'll show you that. That's running here is this DeepStream Analytics module. And what that's doing, it's effectively looking at all of that data as it's coming through, matching it on specific criteria. And then what it will do, it will go ahead and count that data and smooth it out into a format that makes sense for summarizing. And then I can send that up to the cloud basically on 30-second intervals. So I'm not inundated with data.
I think it's some kind of a super filter basically on that video data.
Correct. And what you're seeing here is really just the monitoring of the output of the messages that are coming from that device. And so you'll see, depending on what it gets, if there's multiple entities detected, it will package that up in a JSON payload that contains what it saw, the maximum amount that it saw over that 30-second interval, and where it was picked up based on the sensor ID.
Hey.
But this is just getting that data into that format, right? Now, what becomes fun is then actually being able to kind of view it, if you will, and being able to make sense of it. And so what I've done here, I've gone ahead and forwarded this data out into time series insights. And what we've done, we've sort of partitioned this based on the IoT device connection ID and also the sensor ID. So what that gives me is sort of a way to come in here and look at my device, and I can then go down to the sensor ID that it came from, and we can model a specific type for that. So I've done kind of a couple things here. One that's a catch-all for any type of detections. So anything that this detects, I would come in here and add a new category. So you'll see it's got people, vehicles, bicycles, and road signs. And let's say if I had a model that could detect trucks, I could add that in here as well. And that would then get added into that vehicle catch-all. But if I want to go on something just individual, I can do some filtering to perhaps get down here to just events where the object string is equal to person. And that can allow me to drill down very fine into what those detections are.
And once again, no coding. You've been actually playing around with the data formats and so on from the TSI UI, right? Setting up the models here, and then fine-tuning them without having to write queries in any sort of language or whatnot. Correct?
Absolutely, and that's sort of the magic and power of all this. Now, if you want to look at what this data looks like when it's graphed, I'm kind of looking at this over. This is like an hour-long period that occurred sometime yesterday. You can see. It's telling me here, like at the house, we saw people. Down here, it's telling me I saw people and vehicles in the yard at this particular point. But if I wanted to, I could very easily come in here and let's say, let's see what kind of people were being detected in the house at that time. I can graph that in here, and you can see here's some readings of, here's one person. There was 2 people at one point, back down to 1, 1, 1. You'll see it comes back up to 2 here. So you can very easily sort of glance at, what exactly is being seen over time as this data is flowing into the time series insights endpoint.
Cool. So time series insights, super powerful for you to see what's going on. Now the question is, not everyone can or is able to navigate TSI. So how do you think about creating dashboarding? You've not used IoT Central in your solution right now, which is like great, perfectly fine. Actually, you might have, I don't remember, but basically, here you're exporting all the data to time series insights, which allows you to navigate through that. But once again, not everyone is able to navigate that. So how do you offer or deliver that data that has been analyzed by TSI to someone else?
Well, I think the first thing that you would want to do is you can look at saving views and sharing those out to other people. So if you did want to share your data, that's very easy to do. And if you are starting out and you're curious about how to get started, there's actually some good documentation out there on how to partition your data. And I would say that is like the first thing you do when you set up a time series insights instance, and you want to do it right the first time. You kind of get like a one shot whenever you set it up. But partitioning based on something that makes the most sense. So we could have partitioned just based on the device, but maybe I want to know the device and I want to know the sensor ID. And in this case, I actually tried both, and I felt a lot more comfortable using 2 keys when I was setting up my partition ID, just because it made sort of the querying and filtering and the options, as well as how it was laid out here in this hierarchy that I've created. It made that make a little bit more sense in my case. But it depends on what you're doing and what type of data you're modeling based on what you would actually end up doing for your implementation.
Got it.
Now, once the data is flown into here, and this was exciting, trust me, once you get a system up and running, it's awesome to be able to view the data, especially over time. But there's a cool feature to be able to forward this data into something like Power BI. In fact, the way I'm doing this is using a Stream Analytics job, a second one that runs in the cloud that actually forwards all of the IoT Hub messages into this Power BI dashboard. And the reason for that is if we forward it in that fashion, we can actually generate a live updating dashboard or report. And I'll show you what that looks like in just a moment. But this is kind of like the catch-all where I've got all of my items. I can even come in here and say filter these based on what was seen in particular locations and stuff like that. See that the dog was seen at the pool and things like that. But what gets really fun is once you publish this to Power BI, you can start to ask questions about your data. Like you can actually come into here to this live query editor and say things like last cat by sensor ID, and that'll tell me the last time it has seen the cat and where in that instance, right? So
That's pretty cool. That is pretty cool.
Arguably, the whole reason I built this was to find out where the cat was.
Yeah, totally. And actually, the funny thing that Power BI, not everyone actually realizes that it's not just about building the dashboards, but has this intelligence and this ability to actually dynamically navigate the data sets and delivering not just fixed dashboards or almost printable stuff, but actual really dynamic and customizable reporting and dashboards.
Right, and you could see that here. I mean, I love this. In fact, I set up a one of the small Dell x86 tablets next to my bed that's running this report live just next to my bed, mainly because it's actually kind of useful because I can see here, is anybody home? Is someone in the driveway? Are there cars that are driving by the house? And I can also see when the last time people were seen. So if someone were to walk by the yard camera, I would actually pick that up. As long as it was in the last minute, it will look at that window of data and show me that, which is important information to know. If you want to know, are people outside the home and that sort of thing. Just general.
Actually, you have a swimming pool. So like the day you have family around and kids, for example, you want to know where they are eventually.
Well, and that's one of the things we were thinking about was, when I was asking my girlfriend, I was like, what kind of data should we look at? Definitely we want to know if the animals are near the pool, or if you could tell if a child, maybe has gotten in there just for safety types of reasons, right? You want to know if people are, not in the place they're not supposed to be, and that sort of thing. And you can do that with this. In fact, the magic, if I was to really say like what really opened this up is, when you look at DeepStream, that is performing the real heavy lifting of being able to turn your cameras essentially into sensors, high speed, high throughput sensors too, as we saw. But it was the magic of Stream Analytics that could summarize that data and simplify it over time that has then turned it into something that you can look at, analyze, act on, make decisions based on, and that sort of thing, because of the way that it has been transformed by that Flex job. So if there's one thing that was really important in this solution, I would say it was the Stream Analytics query and how it actually makes sense of that data over time. And it's awesome that it does that at the edge, which then opened up this whole plethora of being able to plug it into, say, TSI and Power BI to make sense of it all.
Awesome, Paul. Thanks a lot. That's a very insightful demo. I suppose you have a blog post coming up or something that developers can go and read so that they can eventually also access all that goodness that you developed here, right?
Yeah, so a couple things. First, you might be wondering, okay, what hardware do I need to build this? Any NVIDIA Jetson device will work here. In fact, I was able to get this up and running on a Nano device prior to. You will notice a bit limited performance just due to it being a less capable device than, say, the Jetson Xavier NX, the one that we were introducing at the beginning of the call. But I also hooked it up to a 7-inch monitor. And the reason for that is I can see what it's seeing, which is awesome, even for debugging purposes, or you hear a loud sound in the middle of the night. It's nice to just be able to glance over and say, hey, is there a box drawn around? Is someone, walking around the house?
Yep.
And then we split that off to the television. So I use an HDMI splitter here, and I can actually turn my TV on now, and I can see DeepStream running on IoT Edge, producing results, at any point in time, which is awesome.
It's your very own security system at home, basically.
You could say that, yeah. DIY to the max at this point, a little overkill. But yes, to answer your question about, how would someone learn how to do this? It's taken some time to develop this, and it's probably going to take even more time to write about it. But what we've sort of identified during the month of July, which we're calling July IoT.
Nice, I like that.
And it's like the perfect time, the only time you can use that pun. But yes, July IoT will be an event put on by the cloud advocacy team at Microsoft, where we're going to release 3 different projects. I'm going to actually be working with my friends Jim Bennett and Dave Glover. And each week, we're going to sort of deep dive into how you can build out one of these types of projects for use in your own home. And I believe during the second week, we will be focusing on this particular project that you've seen here, this intelligent home security. That week is then going to end with a focus on AZ220 IoT developer certification content. And what's amazing about that is, you can use one of these projects, like, for example, this one that we're talking about here, in a fun way to build something that's useful. And that knowledge that you're going to pick up learning that is going to transfer into direct experience that could help you obtain an official certification and be able to, put down on paper that you do know, what you're talking about when it comes to Azure IoT. And, it'll help you in that just by getting that live experience. And all of this will, of course, launch at aka.ms/JulyIoT. We're going to have a whole project board that's in development right now that will have links to all of the content generated around these projects.
Awesome. Well, people know what they have to do. Search for the hashtag JulyIoT, but they can also learn more about the NVIDIA DeepStream technology at aka.ms/IoT show/DeepStream or NVIDIA DeepStream, right? So aka.ms/IoT/DeepStream. Oh, damn it. I can't say that one, right? So guys, aka.ms/IoT show/NVIDIA DeepStream. That's the one. Yay. Paul, thanks for joining the show today. Everyone, thanks for joining as well. Hope to see you soon. And do not forget to subscribe to the show. Paul, bye. Everyone, see you soon.
Bye, everyone.